Here we go. So we're going to be going over section 6.5, which is polynomial equations. Polynomial equations. All right. So you might be like, well, I already know what that is. Sure, we know what polynomials are, but now we're going to be actually solving some things. So that's where equation comes in. Okay. So we know how to deal with polynomials, but we're going to finally start doing some serious math. We're going to be solving for some things. Solving for things. Okay, so start out by going over what we have solved for. All right. So you have done this in the past. You've solved so you have solved things like this. All right. Most of you should know how to do that. It's a linear equation. All right. An example of that might be something like 2x plus 3 equals 0. All right. Now you will learn how to solve things in this form. All right. So we have ax squared plus bx plus c is equal to 0. All right. An example of this one is going to be something like, let's say we got x squared plus 5x plus 6, and we're finding when this is equal to 0. All right. So a couple of important things before we move on. All right. Let's define a couple things. So we've got quadratic equation. Quadratic equation. So, what's a quadratic equation, you may be wondering right about now? Well, quadratic equation is an equation of the form ax squared plus bx, oh, this is looking familiar, plus c is equal to 0. All right? Okay, so now we know we're solving. Okay, so these things are called quadratic equations. Quadratic equations. Okay. This up here, ax plus b equals 0, this is actually a linear equation. This is purely extra. Don't need this, but this is a linear equation. All right. So there's a couple rules though for this quadratic equation of ours. All right. So a, b, and c are in fact real numbers. And at this point, I usually ask everybody, go ahead and name some things that aren't real numbers, and then everyone will throw out a bunch of things like, what about pi? What about square root of 13? What about a decimal, a negative number, 0? And all those are actually real numbers. So the only thing that is not a real number is an imaginary number. Okay? It's an imaginary number. We're not there yet, all right? but if you're curious, you get an imaginary number by taking the square root of a negative number. That's the only time you would be dealing with something that isn't real. In this class, you will see real numbers for now. Okay. So there's one more rule. A cannot equal 0. Because let's think about this. If A equaled 0, we'd have 0 times x squared. So anything times 0 is 0. So we would just have bx plus c is equal to 0. But isn't that a linear equation? We have ax plus b equals 0, bx plus c equals 0. The letters aren't the same, but really we have a constant times x plus a constant is equal to 0. Here, we have a constant times x plus a constant is equal to 0. So if a was equal to 0, this would in fact be a linear equation. So a cannot be 0. We need an x squared term. We need a term with x squared. All right? Go ahead, box around that in your notes. All right, one more thing though. One more thing. The zero product property. Zero product property. All right, so this one goes like, if we have some a times b, where a and b are just constant numbers, just numbers. If we have some a times b equals 0, pause the video, take a second to think. All right. If we know a times b equals 0, what do we know about a and b? So pause and think about that. Okay, I hope you paused. All right, so if a times b equals 0, then we know either a is equal to 0 or b is equal to 0. And both of them could also be 0, all right? But we definitely know at least one of these needs to be equal to 0. So then either a equal to 0 or b is equal to 0 or both. Or both. Okay. So I will end it there. So I'll have this appropriate title on YouTube. This is just the notes portion, and then the rest of the videos will be example problems.